Just made it like
Okay,
just
okay.
now.
Okay, great.
What's that,
Okay,
dude?
so what?
Oh, I thought someone said something.
This is Elliot.
Yes,
Where,
Nick.
where where can we find like what we need to know for the test?
When did you look? Have you looked recently?
No, I'm trying to look right now.
I can't remember where I put it. It's very obvious where I put it. Ugh. All right, coursework. There it is. Chapter 2.
Okay, thank you.
So that first sheet is the chapter 3 equation sheet that you can use. You need to print it if you're going to use it because you'll be locked out. You can't change screens once you're in. There's 4.5 and 4.6, the list that's in 4.5 that you guessed from, and the 4.5 annihilator tables, those are in there to print to use, and then the steps for the variation of parameters, which you really don't need because they're really simple, straightforward steps, but I still put it in there for you. Eight questions, 13 points each. The first two are full word problems with setups and solves. So it'll be one of the word problems that we've done many of. Well, two of the word problems that we've done many of that you'll have to set up from a differential equation, use some initial conditions and solve. So make sure on those that even if you feel like they're not probably the most fantastically set up, that you at least attempt to solve them because you'll get points for the setup and then you get points for the solve. So if you solve the wrong setup correctly, you'll still get points. So don't just quit if you can't get them set up. And then I got other topics on there. Basically, the other topics in the middle are all things from section 4.1. Yeah, just 4.1. Then there is a reduction question. I know that on WebAssign, they use a formula for reduction. You need to be able to do your reduction with the substitution, not with the formula. It's the same thing. The substitution is where the formula comes from. So make sure you're prepared for that. And then section 3 was a homogeneous, which was an equal to 0. There is one of those on there where you have to factor it and find the pieces and put it together. And then there's one each from section 4, 5, and 6. So 8 questions altogether. It's pretty straightforward. It would be what you would expect. Although, make sure you remember that in section 4.5 and 4.4, you have to solve systems of equations. So you better know how to solve systems of equations. You also have to plug into derivatives. So you need to make sure you know all of your derivatives. Make sure you know all those types of factoring. Don't forget about doing a Wronskian for linear independence and dependence, which we will review again in section 6. And then since chapter 3 really went with more of the chapter 2 solves, make sure you at least know how to separate and integrate, which you know there's a bazillion ways to integrate, so make sure you know all of them. And what was the other one? An integrating factor. Lots of those word problems turned into one or the other, an integrating factor or separate and integrate. I really don't remember any of them turning into any of the other crazy substitutions. So there's that, and then the variation of parameters in 4.6. You'll have to do some integration in there as well, so don't forget about integration. Yeah, you thought it was going away, but it's not ever. You know what, I didn't. Oh yeah, that's all I wanted to type in there. All right, anybody else have any general housekeeping questions before we get in here and finish this annihilator? Nope. All right. I don't know which question we were on. Was it, it doesn't seem like we've done 6. Is that correct? Or are we on 6? Or are we on 5?
4.
We're on 4? Did we get 4 done? What?
No.
We're just now starting 4. We only got to 3? What the heck? All right.
Yeah.
Double minus 3y. All right, so starting out with that one, the characteristic equation would be an m squared minus 3m. So we got to factor that to get 0 and 3. So we know our complementary solution is c1 e to the 0x plus c2 e to the 3x. Next thing you're ready for is what annihilates whatever's on the other side. I forgot to open my regular copy on my other device. 8 e to the 3x plus 4 sine of x. All right, so you go to the annihilator list, which you will have for your test, and decide what annihilates each of the 2 pieces. The first piece is the e to the 3x portion. And what annihilates that piece is going to be, I think it's d minus 3. Now, there would be a power, if there was a power with x, if there happened to be like an 8x to the first, we'd have to make it a squared, d minus 3 squared. But since there's not a power of x, it's just that d minus 3. Then we're ready to move to the next piece. The next piece, what annihilates this next piece is, if you look at your annihilator list, let me pull mine up so I can tell you where to look. The internet did not fail me now. All right, in your bottom box, we have a 4 sine of x, and in the bottom that box, it's x to a power e to the alpha x, cosine or sine, whichever one. I'll put cosine because it's the far right, and it's it's the one on the top. So what's going to annihilate is the d squared minus 2 alpha d plus alpha squared plus beta squared, and all of that is to the nth power. So if you take a look at the x part is not there. That just means n is going to be a 1 because it's x to the 0, and you bump it up by 1. E to the alpha x, there is no e part with the sign also, so that means alpha is going to be 0. And then cosine of beta x, beta is the multiplier inside with the x, and there isn't one there, so beta is going to be 1. So our annihilator is going to be second derivative minus 2 times alpha. Since alpha is 0, that one is gone, d, and then plus alpha squared plus beta squared. Alpha squared 0, beta squared 1. So that's going to be a 1. And it's a plus 1. And then the power is 1 because it's 1 more than the degree on the x. And so it's just d squared plus 1. Now, if you want to take the time to go through and show that d squared minus 1 or d squared plus 1 times d minus 3 is going to annihilate that right side, then you can. But if you pick it right out of your list, it's going to. So it's just up to you if you want to be sure. It's kind of like those one type of problems where the left always turns into the integrating factor times y, and most of you, I don't believe, are going to do that. So if you want to go through it, you can, but you don't have to. So the next step is to operate both sides by these two annihilators. So the left will be a d minus 3 and a d squared plus 1. And we're operating on the second derivative, which is a d squared, minus 3 times the first derivative, all operating on the y. And this y here is kind of like the x in f of x. It's just what you're operating on. If you left it out, I don't think it would confuse you at all if you left it out where you were.
So
But
is there not a plus sign between the two?
no, not when you're doing the annihilator. You have to multiply the annihilators together. And even though there's a plus sign there, it doesn't matter. It's got to be a multiply when you're doing the annihilator. On the right side, all of that is annihilated when you do d minus 3 and d squared plus 1. So on the right side, it's just going to turn into a 0. Because it's been a weekend, I do want to run through that, what it would look like, the double check. D minus 3 and d squared plus 1 operating on 4 sine of x plus 8 e to the 3x. I don't know why I switched places. Basically because I started and I don't want to erase. What am I doing? First, inside, outside, last. All right, so the third derivative would be for the first part. The third derivative, the first derivative would be a 4 and a cosine. The second derivative would be a negative 4 back to sine. And the third derivative would be negative 4 cosine. The third derivative for the 8 part, the first derivative would be 24 e to the 3x. The second derivative would be 24 times 8, or 24 times 3, 72 e. Next derivative would be 2/6. Can somebody check my 8 times 3 times 3 times 3 correctly? 8
I
times
think
3.
it's 216.
216. Is that what I said?
Yeah.
Okay, that's what I wrote. Okay. All right, minus 3 times the second derivative. The second derivative of the sine, first derivative would be 4 cosine, negative 4 sine. And the second derivative on the 8 e to the 3x would have been just 9 times 72 e to the 3x. And then the first derivative was 4 cosine of x and 24 e to the 3x. And don't forget minus 3 times the whole thing. 4 sine of x plus 8 e to the 3x. And all of that should reduce down to nothing. So let's see. Here's a negative 12 here when you, or a positive 12 when you multiply that, negative 3n. And this is a negative 12 when you multiply that, negative 3n. So those cancel. Here is a negative 24 e to the x and a positive 24 e to the 3x. And these guys, pretty simply automatic there. And then for the next piece, 216, and here's a negative 216 e to the 3x. So that, in fact, is the annihilator for the right-hand side. So you determine what the annihilator is, operate on it on both sides, and then you reset up your auxiliary equation based on the annihilator on both sides. And so that's going to be an m minus 3, an m squared plus 1.
I have no idea how you got that. I'm so lost right now. I don't know how we went from the d minus 3 and then the d squared plus 1, and then we went to that step.
This is what you get when you operate with the differential operator on both sides. On the right side, when you do the differential operator times your function, you get nothing, because that's what it is. It's the annihilator. We want it to annihilate. On the left side, I have my d minus 3 and my d squared plus 1. And this fella here, I already had. The second derivative minus 3 times the first derivative.
You have to multiply it on both sides.
Multiply it on both sides, just like you would if you were solving this. Multiply it on both sides by 3.
Oh, and are you showing how it gets to 0 on the right side as well, below?
Yeah, I'm just double checking that just to make sure I'm good, that I picked the right annihilator, which this is optional. This double check is optional. But if you don't do it and you've chosen the wrong thing and it really doesn't annihilate, then you've gone through a system of equations and maybe ended up with something, some system of equations that's not even solvable.
Hold up.
Because you
Hold
didn't.
up.
What?
Hold up. All right. So I'm going to chirp in here. So you just said that's all optional. So everything from where you wrote the word optional down, that's all optional?
Yeah, showing
There's
that
a greater chance that I'm going to mess up distributing all those coefficients more than I'm going to mess up an annihilator. That's just common sense right there.
Okay, well, that's fine, but
Or
that's
that's
to
just
double
me.
check that it works. Well,
Awesome.
you are not alone. I know. Hey, has anybody else popped on here in the last couple minutes? Nathan or Blake or Dakota or Ben or Chase or Brody?
Brody did.
I've been here since the start.
Hi, Brody. Hi, Blake. I never saw your name. I'm sorry. I just didn't.
I'm
write
also
you.
here now.
Who's that?
Chase.
Oh, okay. Chase, I haven't heard your voice. I don't think you've spoke to me like since you've been on here, since we've left. I haven't heard you in a month. All right, so no Dakota Benner. What about Nathan? No Nathan? Guess not. Okay.
Nathan, say something. Yeah, he's here.
He is?
Yeah, check the participants.
I can't when I'm on the list unless I close the other app and then I got to open it back up again. Hi, Nathan.
He might be using the bathroom.
Either that or maybe his he doesn't realize he's on mute. I was talking to Ashley the other day and didn't realize I'm mute for like a couple minutes. All right, so what you got to do again is pick your annihilator and do it on both sides. If you pick it right, the right side's going to always be 0. Always, always, always.
And then we add an extra y on the left. What is
I
that
added
like?
an extra y on the left because this means the second derivative of y. The second derivative operating on y. That's what this notation means. Minus 3 times the first derivative of y. Minus 3 times the derivative operating on y. This y is like the x in f of x. It's kind of automatically going to be there. We don't use it for the auxiliary equation anyway. And so if you left that part off, it wouldn't be a deal breaker. It's just a notational thing. All right, so this is what we had from before. The complementary was, what was it? C1. Where are you at, you rascal? C1 plus C2 e to the 3x. That was your complementary. So where we are now with the annihilator is d minus 3, d squared plus 1, d squared minus 3d operating on y equals 0. So you create a new auxiliary equation from what you have now. m minus 3, m squared plus 1. I can factor the d, which would be an m out, and then m minus 3 would be left, equals 0. You don't need the y part. That would be a 1 if you were doing it in your equation. All right, so we have a 3, a 0, and a 3 if I solve these. If I solve this, I have plus or minus I. That means that my full final answer is going to look like that. My full final answer is going to be C1, e to the 3x, plus, I'm going to go down to this one next, C2, e to the 3x. Oops, that's a repeat. Got to slide in an extra x. This one next, plus C3. I probably should have started with that to keep the same order, but too bad. This one last, plus C4 and C5. Now these are the sine and cosine pieces. It's technically 0 plus or minus I. So it's e to the 0x, which would be just 1. Sine of the beta that goes in with the x is the coefficient in front of your imaginary part, which is just 1. So it's sine of x and cosine of x. That is what your absolute full solution is going to look like. Next step is to piece it up. This we already know is a complementary solution. So this piece and this piece are what make up the complementary solution. That means what's left is the particular solution. The particular solution that, had we done the guess and check, we would be solving for the A, B's, and C's, and that's the same thing that we're going to do here, is solve that particular solution for the A, B's, and C's. So I don't have to subscript it. I always go back to A, B's, and C's. Ax e to the 3x plus b sine of x plus c cosine of x. And then you finish the same way you would have before. Now the thing that I like about the annihilator approach better than the educated guess form of the solution is that I don't have to worry about that sliding in the extras because it was a repeat. I don't have to check for repeats because like right in here is where I've already checked for repeats. And so that's kind of like automatically part of the process. So I don't have to worry about forgetting it. So that's what I like best about the annihilator approach. But essentially 4.4 and 4.5, they're the same ideas as far as what kind of questions you can solve with them. And then the finish up is the same also, because you got to finish by plugging it in to the original question and solving for your A, B's, and C's. So the original question has derivatives, 2 of them, I believe, so we're going to need those. But before we dive into the solve part, is that okay with everybody so far? Going once, twice, solve. First derivative, first times the derivative of the second plus the second times the derivative of the first. Derivative of sine is cosine, derivative of cosine is negative sine. First derivative wasn't too bad. Second derivative. We'll keep it separated just like it is. First times the derivative of the second plus the second times the derivative of the first, which would just be A. Then the next one, 3a e to the 3x. Derivative of cosine is negative sine. Derivative of sine is cosine. And then we're ready to plug it into second derivative minus 3y prime. I don't know if I want to put it here or not. I will. Second derivative. Here's an x. I guess that's the only one. 9ax e to the 3x. I was thinking there was going to be some like terms. Yep, right here. 6a e to the 3x minus sine with a b minus cosine with a c. Second derivative. All right, and then it's 3 times the first derivative. So there's going to be a 9. Ooh, but it's a minus, thank goodness. Negative 9ax e to the 3x. And this one, minus 3a e to the 3x. And this one, minus 3b cosine of x. I'm going to put it under the cosine. And then the last one, plus 3c sine of x. And that is supposed to be equal to, the original question on the right-hand side was 8 e to the 3x plus 4 sine of x. So this should be an 8 e to the 3x plus 4 sine of x. And this should be nothing. And this cancels anyway. So as far as my equations go, this one right here, 3a equals 8. That's got to be true. And here's the next one. Negative b plus 3c equals 4. And this piece has to be 0. So negative b plus 3c equals 4. And negative c plus or minus 3b equals nothing because I don't have that one. Keep in mind that it's possible that you have a full ABC and a full ABC and a full ABC. So you'd be solving a system of equations, you know, from algebra 2, like this nastiness or whatever, all full 3 equations, which you wanted to do substitution or elimination. But if I was doing it, I'd probably do matrices and do Kramer's rule with matrices if I had to do that big old nasty thing. I'm not all about doing elimination with 3 variables. But a lot of them come right out in your lap, like this one. Because once you solve for one of them, the rest of them, oh, dang, maybe not. Maybe I spoke too soon. But at least I just have a system of 2 equations. If we do this one for b, 3c minus 4 equals b. If I rearrange the sides and I can plug it in here, negative c minus 3 times 3c minus 4b minus 4 equals 0. Come on, pen, don't go out on me now. Looks like 6/5 for c. And then you can plug that 6/5 back in right here. (18/5 minus 20/5) b is negative 2/5. And then you can go back to where you already knew your final answer was, way back here in brown. This is what your final answer is. You just got to put your A, B's, and C's in the ones that where they go. And then the blue one that was part of your complementary solution, that piece is just going to stay with the C's because you can't replace those. Those would have to be replaced with initial conditions if it's part of your complementary. So take these guys out, the red coefficients, and put your A, B's, and C's in there, and you've got a winner. 8/3 was first. B, I can't remember if B was with sine or cosine. I think it was the -2/5 was with the sine, and the 6/5 is with the cosine. And that's the same thing you would get. This question can also be done in section 4.4's methods as well. Questions on that one, anybody? Oh my goodness. All right, number 5. Five is second derivative plus y x cosine of x minus cosine of x, which happens to be the same as x minus 1 cosine of x. So if we were doing the particular form, we could get it with a linear times a sine and cosine. So ax plus b cosine of x plus cx plus e sine of x. But the annihilator works as well on this one. So first, the auxiliary equation. It's m squared plus 1 equals 0. Not to be confused if it was the second derivative plus the first derivative. Then it'd be m squared plus m equals 0. The one on the right has 2 real solutions, so there's no sines and cosines. The one on the left has 2 imaginary solutions, so there is sines and cosines. So totally different complementary solutions. If you mess that up, make sure you're cautious not to do that. I see a lot of issues with that. All right, so that's going to be a plus or minus I. So that gives me a complementary solution of C1 sine of x. I think I just tried to write too fast. Plus C2 cosine of x. Oh, I got some news yesterday too, you guys. Or last week. I am pretty confident the college is going to fully online in the summer. SIUC did, and we got an email from administration that it looks like we are going to as well. I'm not sure that's all been announced yet, but I'm pretty sure
Is that
that
going to be Canvas? Is that going to be Canvas or Blackboard?
We don't go to Canvas until the fall.
Well, I don't want to be any part of it then.
Were you going to take some online classes?
Yeah, no, I'm not.
What were you going to take?
Spanish and then a programming class.
At Kaskaskia?
Yeah.
Well, some people, the cool people, not me, got like a pilot for Canvas. So you might check with those instructors to see if they have the pilot for Canvas or not. And then they were going to open up we had a couple other spots for pilots for Canvases. I'm going to ask for one, but I probably won't get one. But anyway, they were going to open some. So call the instructors and find out for sure.
We'll do that. Thanks.
Okay. I know it sucks. I'm not crazy about it either, but I don't know. You never know what's going to happen. I'd rather them make the decision now than wait till like the day before and me scrambling to switch everything over to Zoom instead of, and at least you know what you're getting into. So anyway. Okay. So the annihilator for this one, let's see. We are going to have, we got an X and we got a cosine of X. So the power on X, the largest power on X is a 1. And so we have to bump it up. So as far as the annihilator goes, our n is going to be 2. The beta is what's in the inside of the cosine of x's with the x, and that's going to be 1. If there was a sine of x in there, the beta would also be 1. You could have a sine of x and a cosine of x term, and it would take care of that.
Like, does it help that we factored it out halfway or no?
No, I just wanted to show you that because if we were doing the other approach, you would want to think of it like a polynomial times the cosine. So it'd be a ax plus b times the sine of x and a cx plus e times the cosine of x. So that was just for the other one. If there was 2 different cosine angles, so like it was cosine of x and cosine of 2x, we would need 2 separate annihilators for each one of those terms. But I'm not going to give you one of those. We've got too much else crazy going on. The exponent on the e, that's going to be the alpha, and there is no e, so that means alpha is 0, which means our annihilator is d squared minus 2 times alpha is 0 times d, so that middle piece isn't there, which I like, plus alpha squared plus beta squared, that's going to be a 1, and the exponent is the second power, so that's d squared plus 1 squared. And that's what we're going to operate on both sides with. Now on the left, that's going to turn into d squared plus 1 squared operated on the second derivative plus y. On the right, all that's going to 0. And I'm not going to go through the steps to verify that. It is on the completed notes if you want to see it. They're going to wrap around with the cosines and the sines, taking derivatives, but then you got some product rules, and it would take a while. So I'm going to skip that
Miss
part.
Elliott,
Yeah.
you don't have to do the cosine one as well, like the other cosine one.
No, because if you take a look at the list, hold on, let me get back to the page. This differential annihilator operates or annihilates each of these, like from the top down. So yeah, it'll annihilate the x, cosine of x, but it would annihilate the plain cosine of x also. And if it was like an x to the third cosine of x, it annihilate the x to the third cosine of x squared cosine of x cosine of x, plain cosine of x, all the way down and knock them all out. So it takes care of all of them.
Okay.
All right, page 10. Okay, so we got to create a new auxiliary equation, and it's going to be m squared plus 1 squared, and this is an m squared plus 1, which is now an m squared plus 1 cubed. So we have for the first power a plus or minus I as a solution. For the second power, a plus or minus I as a solution. And for this one, a plus or minus I as a solution. That means my full shebang is going to be C1 sine of x plus C2 cosine of x for the first group of plus or minus I. For the next group, it's going to be the same thing, but I have to slide in an extra x. And then for the third group, I have to slide in an extra x. And that is my full general solution. These guys make up my complementary solution. That means these guys make up my complementary solution. That means everything that's left has to be my particular solution. And all the things that are left are all those repeated ones. So my particular solution is going to be an ax sine of x plus bx cosine of x plus c x squared sine of x plus e. You could use a capital D there if you want, but this is a question with the differential operator notation, so it might mess you up. X squared cosine of x, and solve for your a, b's, and c's, which is a page-long solve. And it is what time? 12 till 9. If it's okay with you, I'm going to skip the solve and let you look at it. It's on the completed notes. Does anybody have a problem with me skipping the solve?
No.
Nope. Anybody else? Speak now or forever hold. Great. So when you solve, the A is going to be -1/2.
We won't solve it as long as you promise this won't be in our test.
It will be on your test. You have to solve.
Like
want me to
this
solve
kind of
it?
solve. Like this kind of
This
length
kind of what?
of solve.
I believe
Well,
the
the-
word he is looking for is sophistication.
Yeah, there will be a
Just-
solve. I mean, this has got like some derivatives. You got to take some derivatives and some product rules and keep track of stuff. But when you get to the system, Nick, it's -4c equals 0, 4e equals 1, a -2a plus 2e equals 0, and 2b plus 2c equals -1. It's not a difficult system to solve. It's just a pain in the butt to go through the first and the second derivative and do all those product rules and keep all your terms. Will you have to do that? Yeah, you'll have to do that. I mean, like, not all of them will be long, 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 but that's why there's only 8 questions. So there's not a lot of crazy long solves, but there are solves, and I know that you will make a mistake. Not you, but all of you will make mistakes in your solve. You just got to get to the end. You can do it. Come on. Let's see. The b is in front of the x cosine of x. The c is in front of the x squared. So what was that going to be? That was the 1/4 also. And the e was in front of the x squared cosine of x. Oh, that's a 0. And so put those in, putting it back together. Particular solution is put that there, put this here, put this there. Final solution is the complementary plus the particular, C1 cosine of x plus C2 sine of x, or in the opposite order, whichever order you want, doesn't matter. Plus 1/4 x cosine of x minus 1/2 x sine of x plus 1/4 x squared sine of x. Final answer. All right, next one has a sine, or has a cosine and a sine. Well, just a cosine, but you have both pieces, and an e with it. This one had a sine or cosine and an x with it. Number 6 has a sine, cosine with an e with it, so it's going to be a little bit different of an annihilator. But we always start out the same anyway, and that is solving the complementary piece. All right, so the auxiliary equation is m squared minus 2m plus 1, which factors into m minus 1 and m minus 1, which means my complementary solution, since I have 1's on both of them, is c1 e to the 1x plus c2, it's a repeat, so slide in an extra x, c2x e to the x. My annihilator is alpha is -2.
Can we slow down just one?
Yep. Nick, just let me know when you're ready.
Okay.
Okay. Alpha is your -2. Beta is the fella inside the cosine and sine. So that's going to be a 1. And your n is 1 more than the highest power of x. Well, there is no power of x. So that's 0. 1 more than that makes it n of 1. Your annihilator, which again, you don't have to have memorized. You'll have that list, is d squared minus 2. Is there a 2 in there? Why am I going to say 2 alpha n? Is it 2? Yep, that's it. 2 alpha d, 2 alpha d, alpha squared plus beta squared. Alpha squared plus beta squared this time is going to be a +5. And I'm glad it's just the first power. So our annihilator is going to be d squared minus 4d plus 5. And so that's what we're going to operate on both sides. Again, on the right side, it's going to annihilate it down to 0. That's the whole reason we do the annihilator, is to knock it down to 0. So if you want to go through that and verify it, you can. You don't have to. On the left side, we're going to operate by the d squared plus 4d plus 5. So my left side is going to become d squared plus or minus plus 4d plus 5. And what we already had there on the left was a second derivative, and another name for that is a d squared, minus 2 times the first derivative, minus 2 times the first derivative, plus a single y, which is going to be a 1 operating on y. Now here's how that works again. It said the second derivative. Right here is the second derivative. You have to say second derivative of what? Second derivative of y. Minus 2 times the first derivative, minus 2 times the first derivative of what? Of y, plus 1 times what? 1 times y. You got to have a 1 there in that spot when you pull the y out.
So like on this one, we made the left side basically in terms of d now.
Yeah, we did that on the last one as well, and then turned it to an m. I may have just turned it straight to an m. I'm not sure. Because that's what, I mean, the important part is you're going to turn it to an m.
Okay.
So you can factor it and get that form. Oh, I was thinking I was going to factor to +5 and +1, but it wouldn't, because it needs to be a -5 to factor. That is so unfortunate, because it doesn't factor. And if that's the case, I have to do the quadratic formula. And I see why it doesn't factor, because the zeros are non-real. I reduced that wrong. The square root of -4 is 2i. And when I reduce it by the 2 underneath, it's going to be just an I. -2 plus or minus I. Thank goodness this one's not too ugly. So I have 4 pieces. My full solution is going to be, I'm going to start with the ones first. C1 e to the x plus C2 extra x e to the x. Now on the complex parts, remember it's e to the alpha x cosine of beta x, e to the alpha x sine of beta x. So it's going to be e to the negative 2x cosine of alpha, which is 1x, and then a sine piece. You got to watch out for the English in your directions. If the question was, what is a complementary solution? We were done. Right here's the complementary solution. If the question says, what's the general solution? That's where you have to go through the whole thing. So we wouldn't stop right here. We would go through and we would match it up with the complementary solution, which is that first chunk. This is your y sub c, and that leaves the particular solution to be solved, and the particular solutions where you got to go through and solve for the a and b only this time. And then you have to put your a and b in and put it all back together for your general solution. But this question didn't ask for the general solution. This question asked for, I don't even think it asked for the particular solution. Nope. It asked for the form of the particular solution. The form of the particular solution, we already know. Now, if it asked for the particular solution, you would have to go through and do your first and second, I think it was only 2 derivatives. Yeah, you'd have to go through and do your first and second derivative, plug it in, and find the a and b if it asked for the particular solution. I get a lot of questions on WebAssign from people that have done the whole thing, the whole problem, and it wasn't to do the whole problem, it was just to do short pieces of it. So make sure you are cautious on that part. And I'd pull up the answer key for your test that I have all worked out and tell you how hard the solves were. However, that answer key is locked in my file cabinet on campus, which I cannot access until I don't know when. So I'll have to rewrite it up. If I get a chance to do that before your test, I will be happy to tell you.
Could you just use my test as the answer key? I'd greatly appreciate that.
Okay, I'll think about it. Actually, maybe we should bid that off. I don't know.
I got $100.
You guys will be fine. You'll do fine. And I don't know, not everybody was on here when we were talking about the beginning. Eddie's got to work Friday, so if a bunch of you have to end up having to work Friday, we may switch it out, or I'll just Zoom with Eddie at a different time.
What if we'd rather do Zoom? I don't want to do this thing that we have set up.
Why not?
Because like I want to be able to ask you questions. I know I'm the one person that has like a ton of questions.
Let me think on it. Let me think about what it, because I can't watch all of you at the same time. I'll get
Right.
bored. I'll fall asleep. I'll drool on my computer. Plus, I was hoping on Friday, see, we have a problem, and the problem is that I took Travin's bedroom. His bed is in the garage. No, I'm not making him sleep in the garage. Trace has a queen size bed, so they've moved all their clothes and stuff into one room, which I thought this was going to be 3 or 4 weeks, not 5 months. And I will not make my 12-year-old share a bedroom for 5 months. Maybe you guys share bedrooms, I don't know. But I had a sister, a twin sister, and we shared bedrooms. And I swear on my life that we would be friends today if we had not shared bedrooms. But we had to share bedrooms. And so we didn't have a very good relationship for a long time because of that. I want my kids to have their own space. So basically, long story short, we're taking a room that we don't use very much, and we're gutting it and making a little office for me. So I've got to get that done sometime. Can you? Let me think on it, Nick. I want you to do well. So we'll come up with a fair compromise, I promise. Okay?
Thanks.
Okay. I mean, maybe you do that and I'm still available by FaceTime or something, which I know not all of you have FaceTime because not all of you have Apple, but FaceTime / phone call There's this old thing that you can do. It's actually pick up a phone and call it. It's amazing how it works. I don't know if I'm ever going to phone call anybody else anymore because, you know, if you really want to talk to them, just Zoom with them. This whole Zoom thing is crazy, but they must be having all kinds of problems with the Zoom because they eliminated the possibility of taking out the password. I have to have a password now. Nathan Wilkins, I don't know what he teaches, but he teaches something. He sent out an email, but I didn't read it. And I kept trying to set up my Zoom messages and take out the password, and it wouldn't let me. And after like the 10th time, I thought, I better read that email. And yet, sure enough, that's what I said. All right, last but not least, number 7 is a doozy because it is a triple prime, so a third derivative. But I do like when I read the questions and it asks me for a particular form of the solution. Anytime you see the word a particular form of the solution, that makes me very happy because I know I am not going to have to do a system of equations and solve for A, B, and C. Although that's the algebra part, which is really the easiest part, but it's the most tedious part. So, all right. Auxiliary equation for the complementary solution. Third derivative minus 4 times the second derivative times plus 4 times the first derivative equals 0. If there had been another term in here, like plus a 3y equals 0. There's not, but if there had been, you better be prepared to factor by grouping because it is a fair kind of factor, fair kind of factoring. And if it doesn't work, you better be prepared to implement the P over Q test and do some synthetic division to divide it out. I'm not taking that off the table as far as your test goes. So I'm not sure if you have to do it or not, so don't panic if you don't see one. But I wouldn't hesitate to put it on just because it doesn't factor like you expect it to. I had to put that on my to-do list. I got to work that up today to make sure it's not too crazy. Work on answer key. I may end up cutting it shorter too, so we'll see.
Please.
All right, so take on an M. And factor it, but it's 8 questions, 13 each. I don't even like that. If we go any more, like 5 questions, 20 each, could you imagine if you couldn't start one? That makes me nervous. All right, so e to the 0x first, e to the 2x second, and e to the 2x with sliding an extra x in. There's your complementary. All right, now we got to decide what on earth annihilates all this beast. First piece first, we got a polynomial. To annihilate a polynomial of second degree, it's going to take 3 derivatives. First derivative would be a 10x minus 6. Second derivative would be a 10. Third derivative would be a 0. So third derivative annihilates a second degree polynomial. The next piece I have is
And that covers the 5x squared and the 6x.
Yep. It'll cover 5x squared and any piece that has an exponent that's smaller than 2.
Okay.
Okay. This piece here is an e to the 2x, which is unfortunately different from the third piece, which is an e to the 5x, which means there's going to be not 2 pieces of annihilator required, but 3 pieces of annihilator required. On the green piece, we have an x squared and an e to the 2x. So if you take a look at your page 1 sheet, an x squared, and an e to the 2x. Your alpha is a 2, and you have to go 1 higher than your x squared, so your n is a 3, 1 higher than your highest exponent.
Does
So
it say on the sheet anywhere to go 1 higher or no?
Well, that's what this is. N minus 1 is in my box, and n, that's just 1 higher than your n minus 1.
Oh, okay.
Okay, so n is 3, and your alpha is 2. Every time I say alpha, it makes me think of The Walking Dead. Does anybody watch The Walking Dead? I'm ashamed.
I have no time for TV shows, only
That is
time for differential equations.
You're trying to make me feel bad, but that is the only show that I watch, so I don't feel bad about that. All right, n is 3. So there's my second piece of annihilator. I would be watching Cardinals baseball at this time as well, but no. Even though I just finally switched back to DirecTV so I could get Cardinals baseball, yeah, no, not helpful.
You start watching Tiger King.
Start watching what?
Tiger King?
I need to watch that.
Is this the one about the lady that kills her husband and feeds them to tigers?
Yes.
Bitch, Carol.
Carol Baskins.
Bitch,
I've
Carol
seen it
Baskin.
all on Twitter, but I have not even, is it, what show is this on? What TV station?
It's on
Netflix.
Netflix.
Carol Baskins.
I don't have Netflix. Now that I have this hotspot hijacked from the college, I guess I could get Netflix. That would be
I'm gonna
kinda
tell.
romantic.
You're
I
missing out if you're not going Tiger King. Oh my God, it's insane.
Well, Jackson's girlfriend Haley has Netflix, and when she comes over, maybe I'll start watching it with her. How long will it take me to get caught up?
There's only like 7 or 8 episodes, but
Oh,
you can only
so a
watch
whole
like 2
day.
or 3 at a time or you lose brain cells.
Do what?
Said you can only watch like 2 or 3 episodes at a time or you can feel yourself losing brain cells.
I don't want to do that. Maybe, what if I'm watching and grading differential equations tests? Will that like compensate?
You're going to get distracted, but good luck.
D minus 5 for this last piece. All right, so my differential operator is d cubed, d squared minus 3. I am so glad that we don't actually have to show that all of that annihilates the right side. If I had to show that multiplying this out would annihilate the right side, this, when I distribute it out, would be a third derivative. And this is a third derivative, add exponents, and I got a 6th derivative. I'd have to do a 6th derivative, which would be no big deal on these two, and no big deal on these two. But doing a 6th derivative on this one would be kind of a pain in the butt, and I really wouldn't want to do that. So I don't have to show it anyway, even if I was doing the full shebang. So the next step to the full process would be to put each one of those operating on both sides. So on the left side, we have our annihilator, and it's going to operate on this pink filla here, which I'm going to rename the third derivative minus 4 times the second derivative plus 4 times the first derivative operating on y equals, and on the right side, as long as I've read my charts right, that's a 0. So my absolute big final answer would be, I don't know if I'm ready for that yet. I gotta factor this piece here. D squared minus 4d minus, or plus 4. So it'd be d minus 2, d minus 2. So my absolute final answer would be, for these d cubes first, c1 e to the 0x plus c2 e to the 0x, but I have to slide in an extra x, plus c3 e to the 0x, but I have to slide in an extra x. That'll take care of these. You know what? I think I want to color coordinate those. And because of the other one at the end there, I would also have to have another. I forgot to slide in the extras. Slide in the extra x's, and there's another extra x's. All right, and then let's see, where are my 2's? All right, so this is going to be a C5, e to the 2x, plus C6, slide in an extra x, e to the 2x, plus a C7, slide in an extra x, e to the 2x. And then here's 2 more of those. C8, x squared, C9, x to the 4th. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Ooh, I got that. All right, and then my last piece is a C10, e to the 5x. That is my general solution. My general solution is made up of, I thought I had a highlighter in here. My general solution is made up of my complementary solution and then everything else. So here's part of my complementary. Here's part of my complementary. And here is part of my complementary. That means everything else is particular. The particular form would be, I do like that I have lots of colors here. 1, 2, 3, 4, 5, 6, 7, those 7 pieces. And I would never ask you to solve a system with 7 equations or 7
What about
variables.
WebAssign?
7, no. I don't think more than 3, but that's too many. And usually for the particular, I don't really care. Just a minute, boys, I'm almost done. For the particular, I don't really care, but WebAssign is going to be pretty picky. They're going to want ABCs and stuff. They're not going to want subscripted. So on this tiger thing, everybody's saying she definitely fed him to the tigers. Like, is it like, do you know for sure she fed him to the tigers? It shows it, or is everybody just speculating?
They literally reopened the case about him being a missing person for 20 years now.
Really? Interesting. It's like a documentary?
Give or take, yeah.
Interesting. I'm gonna have to watch this. I do love big cats. All right. That is it. Let me get back to my non-share. Hey, hold on, you guys. I'm gonna put you on mute because I gotta holler at Josh. Actually, I can't get you on mute. I'm just gonna holler. Hold your ears. Trace! Tell your dad to call his Uncle Danny. He keeps calling me. Okay. All right. Did Dakota make it in? I see Ben made it in.
Dakota has been AFK.
I am not sure that I know what AFK means, but
Away from the keyboard.
oh, that's cute. AFK. Did you just make that up?
It's a gamer thing.
It's a gamer only thing.
Oh, gamer thing. Okay.
Something new every day.
Okay. All right. So before you go today, anybody got anything we need to discuss? Besides, I know you want to discuss this test thing. I don't even know if, Chris, to ease your issues with your Chromebook, and Nick, your issues with wanting to make sure. I need to comb my hair. I did brush it, I swear. To ease your issues with me being able to answer questions, I'm not even sure anything's going to be up and running by Friday. So anyway, we'll see how it goes. We'll play it by ear. We'll discuss it more on Wednesday. If they don't have anything set up for me to practice on or go through and see what it's like for you guys, then we won't be doing it on Friday for sure. So, but you do need to get all your stuff done. Some of you have been massively behind. Some of you have been sprinting to get caught up. Thank you. I know that some of you have been doing 2 things a day trying to get caught up. Make sure you're caught up by the end of the week. There's only 5 weeks left. At the end of this week, there's only 4 weeks left, which means for you guys, there's only 3 weeks left, because I don't know what Edwardsville's going to do yet. Has anybody heard anything from them about their summer session?
Yeah, the summer session's open, but it's all online now.
Okay, so it will still start like on, where's
The
the
11th,
calendar?
yeah.
Like the 6th or something like that?
The 11th.
Oh, on the 11th?
Yeah.
I thought it was earlier than that. Did they
Nope.
push it back a week?
I think so, no.
Oh, our final exams were supposed to be on the 11th. So that's right. Okay, so they are fully online on the 11th. Okay, so basically, we just really have to get you done by Friday the 8th. I was trying to get you done sooner in that week. That way, because I figured you'd have to move over there and do all that stuff. But since there's not going to be moving as much involved, or are you still going to move over there, Nick?
Nope. We're going to postpone the wedding too now, so.
Oh, I'm sorry.
Yeah.
Well, better be safe though.
Yeah.
Okay.
Yeah.
I hate to hear that. Okay, so we'll definitely be done, by Friday of that week. I'd like to get you done Monday or Wednesday. I think on the calendar right now I have us done on Monday with the final exam, but we can wait and play it by ear. But that's helpful to know because we have a couple 2 days to play with, and so if we get behind a little bit, not a big deal. So same with this test. If you guys don't feel like you're ready and we need to do it on Monday instead, so you have an extra weekend, I really don't have a problem with that, except that it pushes everything back. And then you'll be cussing me in the beginning of May trying to get everything in. So anyway, we'll discuss it when we hear the blackboard. Thanks everybody for coming today. Everybody but Dakota, that's awesome. All right, anybody got questions for me that I may or may not be able to answer?
Are we going to have another test after this one?
3 tests and then a final. So yes, this
For
is
sure?
a test 2. Yeah. I mean, what do you mean for sure?
Final.
What?
I mean, do we have enough time? Didn't you say there's only like 2 weeks left after?
Oh yeah, we have enough time. Yeah, I have everything spread out on the calendar. Did you see it? These 4.4 and 4.5 were the longest sections. The rest of them, when we get to like 8 and 7, really, we do 2 sections each, and it's really a different approach. But like one of the 2 chapters, I don't know which, is Laplace transforms, and it's in 2 sections when it really could have been in 1. So I have 2 different days for that down, so I think it will be fine. If not, I mean, there's a possibility if we went over that I would have to take out the final or something, but we're not going to, and I really, really, really don't want to do that. Honestly, the final is the easiest test because it's more of an overview and less of a detailed test. And some people after their first test, quite honestly, need the points more on a final and out of the testing category. So if we took the final out, each of the single tests would be worth more, and I don't want to do that to the people that that had that first test not go so well. So anyway, we can talk about it more at the end if we're short on time and get a fair compromise. But rest assured that I want to do everything I can to get you guys through and with decent grades. Some of you, however, are going to have to take some of that responsibility on as well, because there's some slacking going on out there as far as homework and preparation and stuff goes. So I know, I get it. I don't want to do anything either. I spent all of Saturday, I had a headache because I was so stressed out because I have so much to do. But you know what? I did nothing because I had a migraine, because I had a headache, because I had so much I had to do and I was so stressed out. I tried to sleep and I couldn't sleep. It was just crazy. So I get it. It's stressful and it's just weird. So I want to help you out the best I can, but you're also going to have to take some responsibility. And some of you need to crank it up a little. Some of you are doing great. Don't misunderstand me, but some of you need to crank it up. So do what you can. Let me know what I can do to help, because that's what I'm here for. Alrighty.
Oh yeah, did you have a what do you call it? Conference office hours today. That's what it's called.
Yeah, 1 to 2. I put them on. I sent a thing office hours for the full week. I put them on one thing this time. And Joyce helped me download Quigley, whatever that is, so I could send them to all the classes in one announcement instead of like 7. So that was helpful.
I don't know if I got it though. That's why I was asking.
It's listed on your announcements.
I'll double check.
Maybe I didn't hit send as email. Maybe I just put it up as an announcement for everybody. I probably
maybe
did.
That's why.
I probably didn't want to bombard your email, but it's under announcements, week of April 6th, office hours. It's on there.
All right. Thank you.
Okay, so I'll see some of you then. Thanks for recording, Cole.
Yeah, I'll try to get that recording to you a little bit earlier.
Okay, it's no big deal. It's just Dakota, and he hasn't worked on that last one yet, I don't think, so it's good. If you got something that you want to ask about, stay on. If not, click off, and I will see you on Wednesday. Have a good day. It's sunny. Get outside. Enjoy some 70 degrees.